3.4 Graphing Polynomials Day 1. This is when we get to put everything that we have learned in 3.1, 3.2, 3.3 all together and create a beautiful little graph for our polynomial. So running through the things that we need to do each time, please make sure that you get all of this written down so you can refer back to it and make sure you have all of these included with your graphs. We want to find the zeros. Remember, zeros are a synonym for X-intercepts. So when it's asking you to find the zeros, we're trying to find the places where our graph is crossing the X-axis. We're going to locate or figure out what their multiplicity is. Multiplicity refers to the number of times a zero occurs. So if 3 is a 0 and it shows up 2 times, it would have a multiplicity of 2. And we'll talk more about what that means. We want to find the Y-intercept. Remember, for Y-intercept, that's when we are putting a 0 in for X and trying to figure out what the Y value would be. Mid-intervals are going to be new. We haven't done those yet. But mid-intervals is when we were taking the average of the X-intercepts. Okay, so whatever we found up here for these X-intercepts, we're going to take the average of them when they're in consecutive order to get our X value, and then we substitute back in to find Y. People always ask me again about mid-intervals and how to find them, so definitely write that part down. I think people skip over how to do the mid-intervals. Then we will list the end behavior. End behavior, we did back first semester. We'll run through it really quickly again. That's when you're going to look to see if the degree is positive or negative, and your degree is even or odd. Even or odd, and your leading coefficient, I was getting ahead of myself, is positive or negative. And then you have different possibilities. When your leading coefficient is positive and your degree is even, it looks like a parabola opening up. But if your leading coefficient is negative, it's a parabola opening down. If your degree is odd positive, it increases from left to right, but it looks like a cubic. And odd negative, it decreases from left to right. This is also when we use that notation as X approaches negative infinity, f of X approaches blank, and as X approaches positive infinity, f of X approaches blank. I believe we did that in section 2.6 at the very end of first semester, so if you need to refer back to those notes. And then we take all of that information and we graph the polynomial. All right, so let's take a look here at number 1 and kind of go through each one of those. First, we need to find the X-intercepts. So it tells us that one of our zeros, or one of our X-intercepts, is 2. So we can use synthetic division to find the other ones. We need 3 total because it's a cubic. So one of them's 2. What are the other 2? Well, we'll put our coefficients across the top here. You can see why we learned synthetic division. We use that a bunch. 8, 3, 6, 0. It does in fact work there, which is good because they told us it would. And then we turn this into a quadratic, x squared plus 4x plus 3, and we factor it, x plus 3, x plus 1. So that tells us that the other 2 zeros are negative 3 and negative 1, plus we had the 2 that they gave us initially. So step 1 was to find the X-intercepts, and we found 3 of them. That means since we have 3 and it was a cubic, they all have a multiplicity of 1. They only showed up one time. One time, one time, one time. Anytime your multiplicity is odd, and all of these are odd because they're all 1, What that means is it's going to cut through the x-axis. Your graph will cut right through the x-axis when they're odd. When they're even, it'll bounce off of it. And we'll do an example later that shows an even multiplicity. But since each one of these only showed up once, there's no double 2 or double -3. They all have a multiplicity of 1, which means they cut through the x-axis. All right, next it told us that we need to find the y-intercept. Y-intercept is when we put a 0 in for x. So doing that would eliminate the first 3 terms, and we'd be left with -6. All right, next we need to find the mid-intervals. Remember, mid-intervals are when we're going to take the average of the x-intercepts. Now, they need to be in consecutive order. So notice how we have the smallest and then the middle and the biggest. So we're going to average -3 and -1. I'm going to rewrite the x-intercepts down here so you can see how we're doing this. So we're taking the average of -3 and -1. So we add those together, we get -4 and divide by 2. That's how you take an average, add and divide by 2. So right smack dab in between -3 and -1 is -2. Same thing for -1 and 2. Add it together, you get 1, divide by 2, you get 1/2. All right, so those are the x values. Look what I'm doing here. Those are the x values of 2 points. They don't go together in a point. They go in 2 separate points as the x values. We then take those x values and put them into our original equation. So I'm going to put -2 in for this x, and this x. And I'm going to solve it out to figure out what the y value is. And I already did that, so it is 4. Then I'm going to do the same thing with 1/2. Put 1/2 in up here, solve it out, and I get -7.9. So those are my mid-intervals, -2, 4, and 1/2, -7.9. All right, then I want to take a look at my end behavior. What should this graph look like? Well, let's see. It has a degree that is odd and a leading coefficient that is positive. So that means it should look like a cubic increasing from left to right, which means my end behavior would be as x goes to -infinity, f of x goes to -infinity. And as x goes to positive infinity, f of x goes to positive infinity. All right, so I find all of that stuff, and now I go back and start putting it on the graph. So I'm going to put my x values on there first, my x-intercepts. -3, -1, and 2. I want to put my y-intercept on there. 1, 2, 3, 4, 5, 6. Then I'm going to put my mid-intervals. -2, 4, and 1/2, -7.9. So I have all 5 of those points on my graph, and I'm going to connect it in this shape of my end behavior, meaning I'm going to start low on the left, so down here. I'm going to go through all of these points, and I'm going to end high on the right. So my end behavior should be going down towards infinity on the left and up towards positive infinity on the right. So it took all of this information to make that graph right there. And we're going to try that all one more time. So please write this down, pause it, and see if you can go through those steps, and then come back and check to see if your graph looks like my graph. All right, this time it tells us that 1, 0 is 2. So again, we put 2 in the little box and put our coefficients across the top. Then we do our multiplying and adding. And we get that 0 that we're looking for. So we turn this into a quadratic. Now, the whole point of doing that is we can find the other two zeros that we don't know. It's a cubic, so we know there's going to be 3. It gave us 1, so there's 2 that we're missing. So now I need to factor this. I never want a negative leading coefficient, so I'm going to factor that negative out. And then I have negative x plus 2, x minus 2, which tells me that I'm going to get a negative 2 and a positive 2. So if I list out my zeros, I had 2 that they gave me originally, 2 that I found, and then a negative 2. Okay, so look here. So you see how 2 showed up twice? That means that when I look at the multiplicity, it has a multiplicity of 2, because it came twice. Negative 2 has a multiplicity of 1. It only showed up once. So we talked earlier about when it's an odd multiplicity, it cuts through the x-axis, versus an even multiplicity, it's going to bounce off the x-axis. All right, so we did our zeros in our multiplicity. Now we need to do our y-intercept. Put 0 in for our x's, and we get negative 8. And then we want to find our mid-interval. Now remember, when you do mid-intervals, they need to be lined up from least to greatest. So negative 2, 2. We don't need to list our second 2 because it's the same thing. So in this case, there wasn't much of a list to do in consecutive order, but what's the middle point of negative 2 and 2? If you add those together and divide by 2, you get 0 for the x value. And then you put it back in, you get negative 8. So our mid-interval is the same thing as our y-intercept in this case. That's okay. All right, now let's do our end behavior. Our degree is 3. So that's an odd degree. Our leading coefficient is negative 1, so that's a negative, which means it's going to look like a cubic going down from left to right. So we would say as x approaches negative infinity, our graph is actually going towards positive infinity. And as x approaches positive infinity, our graph is going towards negative infinity. So opposite of what it looked like last time. All right, so let's put these points on there. We have a 0 at 2, negative 2, and then at 2. We have a y-intercept at 0, negative 8. And if you just look at those 3 points and connected them, it could look like a parabola. Okay, that's why these other pieces are so important, the multiplicity and the end behavior, kind of using those as a combo. So let's see. We're going to start high because that's what our end behavior says. We're going to go to our first 0, and because negative 2 has a multiplicity of 1, it cuts through the x-axis. So we just keep going. We'll go down to this point, go back up to our next 0, and it has a multiplicity that's even, so it bounces off and heads back down the other way so that it ends low, just like our end behavior said it should. So we use all of these things to put a graph together so we know what the shape of it and what it looks like.